Number 11 is the Chapter 2 homework set. So the first thing you want to do is you want to set up a diagram for the problem. So this problem, it's about a person taking a trip in a car. So draw just a, it doesn't have to be a pretty diagram. So this car is on a journey and we're given two different speeds. We're given the speed while driving, which is 89.5 kilometers per hour. And then we're given the average speed for the whole journey, which is obviously less than the speed while driving because there's a rest stop here. We're told that this person takes a 22-minute rest stop. Okay? So the velocity while in motion is 89.5 kilometers per hour. Somewhere along the way, there's a rest stop, so the car comes to a rest. So this right here represents the rest stop, and we're given the time of rest. I'm gonna put T sub R for rest stop. That's 22 minutes. But hold on a second. We got to pay attention to our units. What was the velocity given in hours? The rest stop is given in minutes. So I'd convert the 22 minutes into hours. So the time of rest is 0.36 repeating hours. 22 minutes is 0.36 repeating hours. Okay, so then the car continues on its journey and comes to its final destination. And we're given the average velocity, so line above the V indicates average. The average velocity for the whole journey is 77.8 kilometers per hour. So from this information, what we want to figure out is the total time spent on the trip, the whole trip. We already have the rest stop time. Now what should we call the other time? We have the rest stop time, which was 22 minutes. Let's call the other time T sub T, time of travel. You can call it whatever you want. I'm going to call it T sub T for time of travel. That's a question mark. And then the other thing that we don't know is the total displacement. So from starting point all the way over to where the journey ends, that's a question mark. We don't have the distance traveled. So we're looking for those two things. We're looking for time of travel and then displacement. Now, how do we go about doing this? So I'm going to shrink this down. I need some room to solve it. Make that a little smaller. Okay, so what we have to do is set up some equations. The key to this problem lies in the equations for instantaneous velocity while in motion and average velocity for the whole journey. What can we say about the instantaneous velocity, the 89.5? What would be the equation for this? Well, what's the basic definition for velocity? Displacement over time, where this time is going to be the time of travel, right? If you think about it, this velocity, the 89.5, like that's the velocity while in motion. You basically take how far the vehicle went and divide by the time while moving, which I'm calling the time of travel. Maybe that's not the best word. Time while moving. Okay? Now, what could we say about the average velocity? So line above the V indicates average. The average velocity, how would you calculate that? That's going to be, again, the total displacement, the total distance traveled there, divided by time of travel plus time of rest. It includes the rest time. Getting these two equations, that's like the hardest part of the problem. Coming up with equations to explain the situation. Okay, so any questions on those equations? So the key to the problem lies with what I did, okay? And in fact, if you're watching this video at home, I would pause and then try to solve it from here. The rest of the problem is just algebra, okay? So from here, how do we substitute these two equations together? What do these two equations have in common? X. And keep in mind, we have everything except for X and time of travel, right? So what we're going to do is we're going to take this equation right here, take this top equation, solve it for X. X is equal to V times time of travel. Then take this equation, solve it for X. X is equal to average velocity, time of travel, plus time of rest. We want to distribute this, so that's going to be average velocity, time of travel, plus average velocity, time of rest. Look, this equation, right? What do those equations have in common? X. So if the x's are equal, that means, so I need to shrink this down. Okay, so now we're going to get V times time of travel equals average velocity time of travel plus average velocity time of rest. So now you can solve this for time of travel. Time of travel is going to be equal to average velocity time of rest divided by instantaneous velocity minus average velocity. That's what the algebra gives. Then we go, average velocity is 77.8 kilometers per hour. Time of rest is 0.366 repeating hours divided by 89.5 kilometer per hour minus 77.8 kilometer per hour. You punch this into your calculator and you get time of travel equal to 2.44 hours, which is not the answer. That's not the answer, because what do they want? The total time. So to get the total time, you have to add the time of rest. So you add the time of rest to the time of travel, and you get about 2.8 hours. That's the total time for the journey. Okay? Any questions on this? That's the hard part, getting the time while in motion. Now, second question was, how far does the person travel? So to find out how far the person travels, it's a very quick calculation. You just go x equals, so looking at the first kinematic, x equals 1/2 at squared plus v initial t. What's the acceleration here? It says right here, constant speed. If the person moves with constant speed, the acceleration is 0. There is no acceleration. So the displacement is just going to be v times t. You know, it's like this, guys. If you're moving at 50 miles an hour for 1 hour, how far did you go? 50 miles. How about if you're going 50 miles an hour for 2 hours? 100 miles. All you're doing is you're taking your velocity and multiplying by the time. And that's assuming no acceleration. That's assuming constant speed. Okay, so now which velocity do we use? Do we use the 89.5 or the 77.8? Well, it depends upon which time you want to use. You could actually use either one. I'm going to use the 89.5. 89.5 kilometers per hour. Now, which time do I use? The 2.44 or the 2.8? The 2.44, because that's the time while in motion, and this comes out as about 218 kilometers. Now, you could have also done, 77.8 kilometer per hour, but then you'd have to use what time? Then use the 2.8, and it should come out exactly the same.